Am I streaming? Yes. Yes, the mic is better this way. Yes. All right. So on this stream, I would like to rewrite dynamic arrays from scratch in C. And the reason why I'm doing this is because I would like to make an actual video explaining how they work. And yeah, for that I need to build a small example. Let's go. I didn't expect I would be streaming like for less than a minute and somebody would be there. But okay, nice to know that somebody already is into it. Void pointers generics type. Yeah, I was thinking, since as I say, I'm going to do like a video explaining how they work, I was thinking of doing like maybe 2-3 versions. Like the first version being the easy one, where it's just a dynamic array of integers, just to explain what a dynamic array is, not what generic types are, you know, make it simple, make it more understandable. Then make one with void pointers, which I've already done in the past. And then the third level would be like making generic functions and generic struct with like some macro tricks. But yeah, I will just start with doing a dynamic array of integers because it's easy, and it's also easy to make the void pointers versions after that. So yeah, let's just do I need a directory? Today only dynamic. I'm not sure. I think the dynamic array part will won't take much time, so I will probably do void pointers as well. Because why not? Let's just mkdir src test. So this, and then touch src. I don't want to call it dynamic array because that's just too long to type all the time. So dr, that's da. I don't know. I don't want to call it like vector because I don't know. Vector is like a mathematical vector to me, or I don't want to call it a list because a list is like a linked list in my mind. And I mean, DA is a shitty name, but yeah, let's just call it DA. So H, let's make a header and a C file, and let's touch tests, and so da.c. Because yeah, I'm gonna do unit testing for it just to make sure it actually works. So I guess there is 2 people here, but I will still explain how dynamic array work as a rough idea of how it works and how I'm gonna implement it. So the way it works is you have just an array, a struct that contains an array, its length, and the actual capacity of the array. And so what you do is, so here, this is a good image for it. So when you add an element, so like in C++ it would be push, in Python it would be append and whatever. When you add an element at the end of the array, if the underlying array has enough capacity, it will just add it because it already has the memory for it. But here you can see in the second example, it added 2 elements, but then it doesn't really have the actual memory to store another one. And so this time, when you you ask for an element to be pushed, it will actually grow the underlying array, which is symbolized by the turtle because it's a slow operation. But then it grows by more than it needs. So it doesn't grow by like only 1 element, it grows like by, in this case, 2 elements, but in this case, 3 elements, and so on and so on, so that the next insertion is fast. And here you can see that the more we add elements to the array, the more it's gonna allocate elements. So here you can see it allocated 2, but next, since we use it a bit more, it's gonna think we're gonna use it even more in the future, and so here it allocates actually 4 elements instead of 2. And so the more it grows, the more it's gonna do allocation and prevision of future use. And so yeah, this is the main concept of it. Otherwise, the rest is just everything is similar to a regular array, like indexing, iteration, and so on and so on. So let me do da.c. So we will have, maybe I should start with da.h, since if and if, let's do like this, define, why not set it to 5 at the beginning and then keep adding 5s, for example? Ah, you mean like constant, like a constant number of elements. Yeah, that's what I was trying to explain, where I mean, it could be okay, like it's still better than just allocating once, like doing an allocation every time you add 1. You could do like 5 at a time, which would be better. But an even better way is to think in the way of like, the more you're allocating to it in general, it's not wrong to think that you're gonna use it even more in the future, you know? Like, since you've already used it that much, maybe you're gonna use it that much even more in the future. Like, I guess it's more like maybe an empirical kind of thing, where people have noticed that's how arrays are often used, and so that's just how it's done now. And so you can see that here there is the growth factor, and so that's the factor that determines by how much it's gonna allocate extra elements that we don't need yet, but we are gonna need in the future. And you see that everyone, like Java is doing 1.5 times the length of the array. Python is doing some weird bit shift thing. G++ is doing times 2 every time. Rest vector are doing times 2 every time. Go slices are doing like 1.5 and 2. Like everyone is a bit like, has different opinion on it. But the point is they do like grow exponentially. So is it true? Do they grow exponentially? Because it's first 2, then 4, then 8, then 16. So yeah, they do grow exponentially. I hope I'm not saying anything dumb here. But yeah. And I think it's just like a matter of like trying and testing stuff out and see what works. I'm guessing in some situation, like your constant adding would be better, but in most, like if you're trying to make a very generic dynamic array, that's what people do because it just works. And if... Okay, so let's make a type def struct, and let's just call it DA. Yep. Whatever, let's just keep calling it DA. Not the greatest thing, maybe I will change it in the future. So what it has is, let's include std_def. I mean, like, we can include std_lib directly, which I think includes this std_def. I just want the size t type, which will be capacity, length, and just let's call it actual array. Like this is the actual array. So that's a struct, and then we just have a bunch of methods. DA, let's do the basic ones. Let's do DA new, which will take, I don't know, maybe nothing. Let's keep it simple, I guess. I could like ask for a capacity in there, but yeah, who cares? Let's make it more like let's make it more understandable for people to learn it. I know it's always better to use size for these kinds of stuff. Why though? Isn't it just an unsigned int? It is just an unsigned int, but it will depend on the architecture of your CPU. Like if you have a 32-bit CPU, it will be an unsigned int of 32-bit. Otherwise, if you're on 64-bit, I think, if I'm not mistaken, that it's actually a long unsigned int. And so, yeah, in my opinion, it's just good practice whenever you want like an unsigned integer to generally use size t instead of unless you have a very specific use case for it. Yeah, it's just good to have like standards like this. Let's do void da destroy, which will take a da pointer. And yeah, let's just make those two first. So include k.h, and then let's copy those here. Let's actually put the h on the right. And so we do da pointer da. I think I'm gonna change da because I really hate the name. Dinar. Yes, that's not great. That's not great either, but dinar. Yeah, dinar. It actually sounds like an old currency. Like, isn't the dinar? Isn't it like the currency of India or something? Wait. Dinar. Dinar. Isn't it a currency in several countries? So it was the currency of like the, I don't know, some Mediterranean country. Okay. Yeah, in the Middle East. Din array, maybe it's slightly better. I don't know. DA is too vague. Now I have to. Better to rename everything now than later. Din array. Yeah, sounds good. Fine. Din array. Din array. Din array. Dynamic array. And let's rename this file dynamic array.h. Rename this to dynamic array.c. Can do that apparently. Oh yeah, not remove. Rename dyn array like so. Okay, so back to where we were. Dynamic array. So dynamic array. Let's just call it. Yeah, for the variable name, I guess I can call it the DA. And now we just malloc of size of dynamic array like so. If DA is equal to null, we return null. Then what we can do is DA. Yeah, I have to do this. Capacity is equal to 0. Length is equal to 0, and array is equal to null. For types, we have to have parentheses. Return DA. Why pass void as an argument to the function isn't the same thing as leaving it empty? Yeah, it is. Now in modern C, it's the same. I'm just used to it. That's because in like if you put like an old C standard like ANSI C, it's mandatory to avoid. I think so. Yeah, I just keep doing it out of habit. Can I allocate an array of size 0? Yeah, that doesn't make sense. I wonder what is the behavior of realloc. What is the behavior of realloc if you pass it a null pointer? The realloc function changes the size of the memory block pointed by the PTR. The content of the memory will be unchanged in the range from the start of the region up to the minimum of the... If PTR is null, then the call is equivalent to malloc. Okay, yeah, that's fine then. And so dynamic array destroy. I have to DA here. Let's keep it like this, and this is just if DA array is different than null, we do free DA array, and we do free DA, like so. And let's already start doing tests, and for this I would like to copy I think a Meson build file here. Let's see, so the project is dynamic array. Sure, that can... I'm just copy pasting what I did for another project because I'm just too lazy. So there is no executable for this file. cp sed test meson.build in tests test meson.build, and it's dynamic array. There is no other thing. Test criterion, yeah, all that is fine. And I need to again cp like this, src to src, and let's see src meson, which in my case is just dynamic array.c. And if I go in test, I can move test DA to test dynamic array.c. Alright, let's do a terminal on the side. And so test dynamic array. And here I just have to include criterion / criterion. And let's do a test of dynamic array new. And let's just do cr assert false. Just maybe cr asserts 0, like so, to make sure it works. Meson setup builds, okay, and then ninja build and build test criterion. And it works. All right. It works. Next, what we need is include dynamic array, like so. Then we need to do DA is equal to dynamic array new. Whoa, that's strange. Does dynamic array already exist on my system? No. Okay. What is this? Dynamic array. Huh. Can I know where it's from? No, I cannot. Okay, I'm just gonna, I guess, pray that I'm not already Is it C dynamic array new jump? Is it something that exists? Doesn't look like it. Doesn't look like it. Okay, whatever. Maybe some weird auto-completion thing. So like this, and then we can do here assert not null DA incompatible integer to pointers. Let's see. Preset declaration of function dynamic array new. Ah yes, I forgot to change it here. Dynamic array, and same here. Like so. Okay. So we have to assert it's not null. We have to assert that that the array is null. We have to assert equal DA capacity is equal to 0. I would like you to stop importing stuff randomly. Editor length, like so. Okay, that was easy enough. And destroy. We do this, and then we do dynamic array destroy of DA, and this one is just expected to to not crash, I guess. Yeah, great. I'm gonna quickly do a git ignore so that I don't have the cache thingy. Git ignore. So the cache we don't need and the build we don't need. We do them. Okay. If I do FD, yeah, okay, that's better. Shouldn't you check if it's already destroyed? Yeah, I know people like to do that, but I really don't like to do this in the TC. I don't know what TC is. Test case. Shouldn't you check if it's already destroyed in the test case? How would I be able to do that? How could I check that it's destroyed? I mean, I guess there is maybe malloc get state or stuff like that to like actually interact with the internals of malloc and check if something has been freed, but that sounds like overkill to me. Also, yes, the test cases are mostly for like sanity checks, and like this method, this function is like 3 lines of code, so yeah, don't care that much. I think you have to stay pragmatic sometimes. So what we need to do, is dynamic array.h. Then we're gonna have we are going to have like a dynamic array resize, I would say. Refit? Wait, no. I think it's called resize in other programming language, if I'm not mistaken. Also, quick thing, I need to copy from the manual project as well the clang format file. Yeah, so that's so yeah. Setup reconfigure. I think I need that, and Ninja say build. I think now I have the possibility of using clang format here. Yeah, okay. Can I use this? Yeah, apparently it doesn't work. Anyway, I'll fix it later, it doesn't matter. So resize, and then we want a size t. So that will be to change the capacity of the thing. We want a thing to resize it. We want just a thing to grow, which is kind of like an automatic resizing, and we want like push. I think push is good. Yeah, those are like the three main thing that we want to use, I think. So resize, that one will be rather simple. So DA size, I don't know, capacity, let's call it. I don't know, I could call it like update capacity or something, but in most languages, I think it's called resize. So dynamic at yeah, in my previous implementation, I did like some kind of getter, but I think, yeah, I really think I don't care. Like, I'm not gonna do an at function because it's like one line of code. Although, I mean, I could do bound checking and so on, which will be like maybe 5 lines of code or whatever. But I just think, especially for an educational project, is overkill, and especially in C, it's overkill, because like in C++, you could have like method or operator overloading, which would make it like clean and easy to use. But in this case, I really want to keep it simple, and so if people want to interact with the array in a for loop or by indexing it, it's just gonna be DA, then point to array, and then your index. That's how I want people to use it, I think, because it's just the simplest way. And it integrates already with for loops and so on and so on. So it's just the most pragmatic approach, simple approach. So in this case, I want DA capacity to be equal to the new capacity. And I just want DA array to be equal to realloc of DA array and capacity, like so. And yeah, if it fails, yeah, because this can potentially fail. Yeah, I don't know. I don't really want to bother with allocation failures. I did that again in my previous implementation of this. It's so, like, it's just so clunky. Like allocation failure happen so little that yeah, I don't think I care. I think I care so little that I'm gonna do like a static void x malloc ist size. If you're going to check for failing, how are you going to do it? With simple if. I'm going to check for failing. What do you mean for failing? You mean not the indexing failing or the allocation failure? But yeah, my way of handling this is basically just to crash if there is an allocation failure, because I'm too freaking annoyed with like handling failure of allocation all the time, especially for like an educational project like this. So if mob look, we have lists in C now. Dynamic array son, dynamic array. But yeah, in Python we have its list. Allocation, yeah, I'm gonna show you how I'm gonna handle the allocation failure. Look, it's gonna be very simple. Like if pointer is equal to null after return of malloc, I just do abort. And otherwise I return p. And now it's yeah, it's simple. X malloc is my new malloc. There you go. So I'm just going to do that, and then you don't have to worry ever again about something being a null pointer, because your application will just crash if it does. But as I said, it's an educational project, and and like it will never crash for allocations realistically. So yeah, this is the best way to handle allocations failure in this scenario, in my opinion. So yeah, here I use xrealloc. I mean, if you look at languages like, for example, C, C++ or Python, like what do they do? Like, let's say you do Python append to a list, and like there is an allocation failure. What do you think Python does? It just crashes because, yeah. Or maybe it throws an exception. Ooh, hooray. Are you gonna handle like exceptions every time you do append to a list? Of course you don't. You just let it crash. So yeah. So I'm trying to justify myself as if you were like saying I did something bad, but I mean it's not what you said. It's like so many people taught me to absolutely every time handle allocation error in C in a clean way. But then I realized that yeah, nobody does that unless there is a very specific context for it. So yeah. So resize is just this. Then grow is just. And by the way, this is like the key function of dynamic arrays. Where, I mean, it's very simple, but you just do DA, like just resize the dynamic array. And this is its original capacity times 2. And that's it. And that's it. And you can do like static const growth factor to make it clear is equal to 2. And let's make this, I don't know, size t, because why not? And this is growth factor, like so. And yeah, that's all this does. It's just a realloc with a constant factor to it. And then we can finally have our push, which will be int, I don't know, just elements. This is DA still. Like so, and I forgot in the push, we push an integer. And all that does is if we run out of capacity, we do if DA length is equal to its capacity. Like, I mean, realistically it will never be greater than, but let's just say it will be greater than. We can grow it. We just do dynamic array grow, like so. And now that we've grown it, we can do DA array DA length -1. Actually no, just DA length is equal to elements, and then we do DA length plus. I know I could like put it there, but let's not make it confusing. Like this, and yeah, that's pretty much it. Now that's it. So when you push a new element, you check if you have enough size. If you don't have enough size, you grow the array, the dynamic array, and then once you have more space for it, you just append the element at the end of the array and increase its length by 1. And yeah, that's pretty much it. There is no extra tricks. Yeah, I think most of... I would be curious how they end up with those numbers, like especially the Python one, like kind of a strange way to do it with left shift, right shifts, and addition and so on and so on. But yeah. The growth factor for a dynamic array depends on several factors, including a space-time trade-off and algorithms used in the memory allocator itself. For the growth factor A, the average time per insertion operation is about A divided by A minus 1, while the number of wasted cells is bounded above by A minus 1 times n. If memory allocator uses first fit allocation algorithm, then growth factor. For the golden ratio as well as the value 1.5, many textbooks, however, use A is equal to 2 for simplicity and analysis purposes. Yeah, we're just gonna use 2 as well. I think it's fine. In my previous implementation, I think I used the Python thingy because I wanted to be fancy, but yeah, who cares? Golden ratio mention. Yeah. I mean, yeah, if you want to be fancy, you could use like the golden ratio and so on, but who cares? We're here to learn about dynamic arrays, not like the fancy thing. So this dynamic array is going to support push, pop, and all the stuff. Yeah, it's just mostly educational for now. I'm gonna see. Yeah, pop is a good one as well, which is also extremely simple. Push, pop. I guess we can return the int we just popped. And so DA, and then so the way we pop is we do DA length minus minus, and here as well, if there is no element to pop, I'm just gonna crash. Like I'm not gonna return -1 or some weird stuff. Like if DA length is equal to 0, we just do abort. Otherwise, we just reduce the length by 1 and return DA array DA length. Is that correct? Do minus. So if the size is of 1, there is one element, we do minus minus, then the length becomes 0, and then we can return this. Yes, that's fine. What does abort do? Yeah, it's just a more direct way to exit a program, like abort. The abort function first unlocks the SIGABORT signal, then raises that signal for the calling process. Yeah, it's just a more forceful way to exit, as long as other cases of abnormal intermediate function are not called. So yeah, for example, you can, for like a normal exit, like with Control C or something, you can generally register exit hooks with @exit, like it's functions that get executed whenever you terminate a program. But with abort, those are not even called, and so on and so on. I could also just use exit, to be honest. I just, yeah. I just want to make it clear that it should never happen. So yeah, here is our implementation of dynamic array pop. So we have push, pop. I mean, realistically, the user is never gonna grow the array itself. So maybe I could make this function private. Static declaration. Let's not make grow public. Wait, but pop should return the popped element, right? Yeah, it does. Yeah, there is a return. There is a return of the last element. I mean, it's not mandatory. There is like pop function that just, yeah, decrease the length by 1. But yeah, sure, why not? Let's make it return the element. So we have destroy and so on. Let's make sure the test actually still runs. So yeah, the test runs. Now let's test dynamic array. What else do we need to resize maybe? Sure. Test quickly resize. Let's make a new dynamic array. Let's do then dynamic array resize of DA, and let's just resize it to 10. Now assert equal that DA capacity is equal to 10. And let's also assert that the length did not change, so that it's equal to 0 before and after resize. Yeah, I'm too lazy to dig into the malloc internals to make sure that the allocation actually happened. We're just gonna assume that it happened. Maybe I could actually like assert that it's null before, like the array, the underlying array, but that after a resize, it's not null anymore. I think that's a decent enough test. Let's see if that works. Great, it's passing. Let's make it fail on purpose to check that my thing is okay. All right, so that's resized, and then we're gonna do a test. Dynamic array push. So push, which again we're gonna create a dynamic array. We're gonna again assert that its length is 0. Then we're gonna do dynamic array push. Let's say let's just push 1 into it. Then let's make sure that the length is equal to 1 and that the capacity is greater or equal to 1. Oh fuck, there is no GT greater than. I want the capacity to be greater than 0, I guess. There is no greater or equal? It's strange. Here, assert. CR assert greater or equal. It doesn't exist. Oh, okay, it's G equal. Okay. So we want it greater or equal to 1. And we finally want assert equal that DA array 0 is equal to 1. Let's just make it 42 because there is too many ones everywhere. I need a value that I can distinct from the other. Okay, so at least we know it doesn't work. So capacity is not greater or equal to 1. So it should have went into the grow thing, and then we do capacity is equal to new capacity. Ah, yeah, because, okay, the growth factor is of 2, but our initial capacity is of 0, and so, of course, that does not work. So we need to do if dA capacity is equal to 0. We need to do capacity is equal to 1. Sure, that works for me. Okay, now it works. Then we need to push. I'm just gonna keep incrementing it like a few times. Greater or equal to 2, let's see, greater or equal to 2, and let's go for like 3 elements, and 44, and that is third element of the array. And it still works. Oh, great. So that's the push that is tested. Then I want to test the pop, and so dynamic array pop. And so again, I'm gonna like assert this. Then we've already tested the push, so let's just push a bunch of stuff. So this assumes that push is working, which is not a great thing to do in unit testing, but I don't know, since it's just a personal project that I'm quickly doing, it's okay. And so what we want to do is let's just create an integer that will be -1. Then I just do x is equal to dynamic array pop dA. And so what we want to assert is equal that dA length is equal to 2 after this. We want it that before that the length is equal to 3, and we want to also make sure that the element that was popped is 44. And so we just repeat those things 3 times, where this should be 43, this should be 42, this should be 0, and this should be 1. Yes. And maybe I should like make sure that my tests do not have like memory leaks. Destroy. I don't know why they have like this GMP every time. My autocomplete is kind of funky. I guess memory leaks in tests doesn't matter. Yeah, memory will be freed when the test process exits. Yeah, who cares? Okay, so pop also works. Let's make it fail on purpose, just to make sure. Yes. And also, if I pop one more time, let's make a test that. Actually, I can test that my thing will crash. Let's test pop crash. Signal, I think, would be sig abort. Yes, that one. Oops. Yes. So let's make just a new dynamic array, and let's pop on an empty dynamic array. Oh, that doesn't work. Sig abort undeclared here. Stdlib. Guess man signal.h. It's there. Let's see. Include signal.h. Yes, that works. Let's compile it. Okay, so it does abort if we pop on an empty dynamic array. That's good. I don't think I can realistically test the allocation failure, but I don't think I should. Like, who cares? Alright, that's pretty much it. I wonder if I should just make a video about this, or if I should like implement a bit, because I don't know. I think it's already like it's only like 60 lines of code or something. So it should be very easy to understand it and to make a like an educational video about it. I guess I do need like an example executable to with a bunch of prints to show the behaviors and so on. But besides that, I don't know. I could definitely have fun and like implement like a bunch of extra functions. Yeah, I'm not sure. I think maybe a thing to make it easier to do a demonstration would be just a from array method, which I could put at the top, I think. I could do dynamic array, pointer, returns, and score dynamic array from array. Yeah, I guess I could just call it from, because what else than an array could you get it from, you know? Sure, let's just call it from. And so this is integer. So it's an integer, an array of ints, and it just has a size to it, length, like so. And the implementation will be rather straightforward, where we just have a DA is equal to dynamic array new. So we create a new dynamic array, and then we cannot assume that this is already allocated with malloc. So because this could be like a static array or a stack array. So let's just do DA array is equal to xmalloc xmalloc of size of int times length. Then we do DA length is equal to length, and DA capacity is also equal to the length, and we just return DA. And I think that will be it. Oh, no. We have to mem copy into DA array. We have to copy x's for size of int times length. So we just copy the original array into the new array. And I think memcopy is into a string, if I'm not mistaken. Yes. Okay. So yeah, let's quickly test that as well. Don't have to have this. Test dynamic array. Let's just add it after the new test dynamic array from, and let's just do int x's is equal to 1, 2, 3, 4, 5, like so. Actually, just 1, 2, 3 for my ease of use, and we just do dynamic array DA is equal to din array from, then we do x's, and we do size. I guess we can just do 3 here, it's fine. Yeah, who cares about like making it possible to dynamically guess the size. It's a unit test. So what we need to assert is, well, that is not null. That would be nice. Then we need to assert that the array is not null, so that it has allocated something. And let's assert equal DA length is equal to 3, greater equal the capacity. I mean, here we know it's equal to 3, but it should be greater or equal to 3. Then we can just assert every single element. So 1, 2, 2, 3, like so. Okay, and that works. Let's make it fail on purpose, because paranoia, yeah, that fails. That works again. And so, yeah, I have a possibility to create a dynamic array from a regular array now, which is nice. So, can I think of anything else for my educational video before I start with void pointers and like generics and so on? Not sure. I am not sure. So I can, well, let's just try to touch example.c. Example.c, which will just include dynamic array, which will just be a simple main. So, and we do dynamic array, DA is equal, dynamic array new, dynamic array new, actually, I'm realizing now that I should maybe have a little debug function called dynamic array print, just for my ease of use, like making a more comprehensive example, which will just very simply be for size t I is equal to 0 while I is lower than dA length. Yeah, sure. Let's just make a regular print, because I think I'm also gonna want to print the length and the capacity. And we just do printf. So we want to put an integer, which will be dA array I. Need to include stdio, and then we do if I is equal to dA length -1. So it fits different. We also want to put car a comma between the elements. Like, I'm just doing that so that we don't have an extra comma at the end. No need for testing this, but it will be handy for the example. Main, no, I called it example. And so I want to do dynamic array push dA. We want to push like 42 and so on. And next we want to do dynamic array print DA, like so. And we need to do maison.build project dynamic array. We want to add an executable called example, which will be sources, which I don't know what the fuck sources is. But it's just example.c. Does that work? Seems to have worked. Build example. And so yeah, it's only 42. Yeah, my camera is probably hiding that. So yeah, for now it's only 42. And I'm just remembering that at the end I should add a new line. And so let's now push a bunch of random numbers. Sure, why not? And let's print it again. Yeah, I have to build it, then run it, and then we see that there is a bunch of numbers. But what would also be interesting is printf. Let's just do capacity is this, and length is the due length. So and we do DA capacity, DA length. I haven't included std.io, so that we can show that. No, build it. So at the very start, the capacity is 2 and the length is 1. Oh yeah, no, I print it after the push. Okay. So we have to, I think, print it before the push, after the push. Let's print it a bit after. Wait, what? Capacity. Ah yeah, fuck. I'm always confused that I forget to build. So we start it. Capacity and length are at 0. Then we push one number, and the length is of course 1, but the capacity is of 2. Then we push 5 numbers, and of course the length is 5, but the capacity is actually 8. So there is like 3 more spaces, empty spaces, that are now wasted space, but will make future push to the array extremely fast until we reach 8, and then it will be a slow allocation again, and so on and so on and so on. Why capacity 2? Didn't you put 1 at the beginning? Yes, but I mean, it doesn't really matter that it's 1 or 2, huh? But here I put, like, indeed, if the capacity is 0, I put the capacity to 1, but then it still gets multiplied by the growth factor, which is 2, so it's just 1 times 2. But yeah, I could like force it to start with a capacity of 1, but like doesn't really matter in my opinion. So yeah, and yeah, that works as expected. And I think with this kind of example, I could already make a video, since the goal of the video would just be mainly to show like the allocation scheme that is used for dynamic array. So the fact that it's a bunch of wasted space, but in exchange you have an extremely fast append, like a push to the array, until you reach your capacity, and then it's a slow operation. But then and also the fact that there is actually a growth factor that is different per language. So yeah, I think that's a good enough video to explain like the basics of dynamic array. Yeah, that the insertion are constant time unless you have a reallocation, which is then... Oh, I forgot... Oh wait, no, it's okay, it's doing that under the hood. Okay, yeah, I'm got confused because the last time I did this, I didn't had access to realloc. And so I had to like copy the memory myself. But actually here, since I'm using realloc is doing the memory copy for me. So yeah, that's even easier. Okay. Yeah, I think that's it. I think I will commit this. Can I do Silong formats? Can I do Silong formats? Isn't there like... Okay, that's better. So everything is formatted the way I like it. I mean, hopefully it is. Yes. Maybe I should stop putting the type above the... I mean, I like it because they're all aligned, but it's also a bit annoying. Maybe I should stop doing that. Derive pointer alignment, align consecutive declaration, always break after definition return type. I think I can command that. Fuck. Why doesn't... Okay, it wasn't that. Always break after return type. Okay, so that was it. I think it's a more sane way to do it. I mean, I prefer the other way, but I think most people are used to this way, so I will just keep doing it as to not confuse people. Alright, like that, they're aligned. That's perfectly fine. Alright, let's do a little commit. Serge, initial commit is basic dynamic array implementation array of ints push pop and so on. No GPG sign. Alright, so that will be the commit for the actual video. And it took me 1 hour to implement this name. So now the fun part, where I try to do generics in C. Because I know how it works, but I'm not sure. I mean, Mason told me he wanted void pointers. But I think, and that's what I did in my previous dynamic array implementation, but I think, but you run into some issues with that. Because, of course, usability issues, I mean. Like, if I just replace this int pointer by a void pointer, that's basically it. And then I need to replace my ints by voids and so on and so on. But then it means that every single element of your array kind of needs to be a pointer. Like, I mean, you can like store ints in a void pointer as well, but that involves like a shit ton of of conversion. Like if you want to iterate over the array, like now that it's a void pointer, let's say I would like to store ints instead of it. My solution is either like you have to do 1 malloc per int in your array so that you actually have pointers, but that's clunky as hell. So never doing that ever. After you replace int with void in dynamic array push, how to deal with it from user side? Will user need to cast? Yeah, the problem with this approach is that the user will need to cast every time. So if they do like a for loop, whatever, let's do I0, I lower than length. I mean, you can fill in the blanks here, but then it will have to do like the array, then I, and then it will get a pointer, but then it needs to like cast this to an integer, which will raise warnings and so on. And so, like if you want to print, like he needs to cast it explicitly to an integer every time he wants to use it, or like if he wants to like do a dynamic array push, he will say DA, and then he will have his integer like so. But then this will be a void pointer, of course, and so you need to like cast it to a void pointer when you want to push, which is, I mean, it works, you know, but it's not easy to use. So that's why I won't do this. I mean, okay, it's not easy to use unless you have pointers. Like if you have like a dynamic array of structs that you and each of them are like malloc, then it's easy to use, but otherwise it's kind of clunky. So how to make it effortless to the user as possible? Yeah, well, then we have to kinda emulate C++ templates, but in C, which is gonna be like painful for the implementer, so me, but less painful for the user. And I think I explained this in one of my YouTube videos, which is called macros stringify and something. Just I should put that in this macro variable arguments. No anonymous struct macro stringify and tokenize. Yes, that's it. We'll put it in chat. Poop. Maybe I should put it in the description of this live as well. So yeah, that's where I explained this, and I have to actually think on how to do this. So we're gonna have a macro that is called, and that will basically generate all those functions. And the downside is, unlike C++, the user has to explicitly say that he wants those functions for this type. C++, the compiler understands that if you have a vector of int, it will automatically generate every functions for it. Let me think. Maybe. I'm not sure what is cleanest. Either I do like what? Do I put every single of my functions in a header? And then I have kind of, yeah, I'm not sure actually. I've never done this. I've done it on a very small scale, but wait. And there is also a new C thing, isn't there, like C99 generic, which could maybe help me. C11 even. So there is this thing which allows you to define a macro that is generic, and then you just list the type and then list the associated function. But that means I would have to implement each of those functions, which I don't want to do. I want to automatically generate those functions. That's not what I want. So the macro is going to generate all the functions for all the types. Yeah, the user is going to say, I want a dynamic array for ints, I want a dynamic array for floats, and I want a dynamic array for this random struct that I created in my program. And it's going to generate 3 copies of every single functions for each of those types, you know? That's the goal, at least. Not sure how it will go in practice. I think what I could do is like define a dynamic array new type new. Let's just do new type. Let's call it T. And now it's where the code becomes extremely disgusting. So no, it's still a pointer, but say we have type T, which will be like so. And now I need to like put this kind of stuff everywhere. Like so. Let's CLang format. Can I reformat this? Okay. Now I need like a wall of anti-slash already, so that's not great. The array from again will be just a type. Yeah. It's just I don't think it can be T, otherwise it will be interpreted as like something weird. This has to be T as well. And this has to be T as well. Of course, the downside of doing this is that if your struct is too large, it will be passed on the stack, and not as a pointer, I mean. Yeah, I think GCC can pass large structs as arguments, so it's okay. Yeah. If your mind is kind of going funky right now, it's okay. So yeah, you can have like a macro that takes a type, and if you prefix it with a double hashtag, it will actually use it as a token. Because of course, if you like just use T, it will think that just literally the letter T represents a type. But this means the text that is associated with T is actually a token itself. So the goal then is to call this macro like so, new type, and then you just literally put int in it, or like in my example floats or long ints or whatever. Actually shouldn't probably put cannot type a semicolon at the end. So yeah, that's how it should work, at least. As you can see, I have a shit ton of errors right now. So I think the way to go is oh yes, as well, it's gonna be, I need this to actually be like this, because otherwise you have conflicting type names. Oh, and I need every single function to be prefixed by T like so. Yes, and I need like a special thing for this to work, because of course, like this is not really generics. Like it won't have the same name. So like if the goal is to have like dynamic array int push, but then you will also have dynamic array float push, and so on and so on. I have no clue how it will handle long ints, since it cannot have space in it, but let's not worry about that for now. And so if I do this, parsed formed int invalid processing token. Let me fetch some water. Alright, I'm back. I think maybe a good idea, because that's my initial plan, but a good idea would be to do like kind of a bit of a research. Put for the user, will they need to explicitly call dynamic array int new? Yes, they will. So it's either, I mean, it's a bit of a trade-off. Either you do a void pointer, and then you have to cast every time, or you do this method and you have to write the type every time. I find that, I mean, I don't know, I've tried the void pointers approach and it's horrendous, so I just want to try this, which I've never tried before, and see if it's less painful and a bit cleaner. I think it will be a bit cleaner. I mean, implementation side will be horrendous, but the user side should be a bit cleaner, in my opinion. Also, I wonder, like, I mean, this is getting like funky, huh? But since there is this new generic in C, where you can actually have like this function, like for example here, CBRT will either call the individual type function. Can I like automatically generate this according to what the user wants? And then you wouldn't have to type the type into the function name every time? That's kind of fucked. Okay, my brain is becoming mush. And also it seems it's an expression, so can an expression be also a struct? What would be more convenient for user ing? That would be more convenient. User. Yeah, of course, that would be more convenient, but I don't know if I can do it or if it's like how painful it is to do it and see. Or maybe I just switch to C++ and use templates. Hell yeah. But no. Let's try this weird approach. So how did I do it in my video? Because I already forgot since I used this feature maybe 3 times in my life. So stringify tokenize. Okay, no sound from YouTube. That's nice. Let me show me my example myself. So yeah, here I showed the stringify, which is funny, but okay, who cares? Okay, so prefix like so. Okay. Yeah. Okay, that works. How did I do the function? I did like so. Okay. Okay. In my case, I think I need a special method. Or I just don't care and put it at the end. Because like this is not gonna work because it's expecting like t_new to be a variable, a macro variable name, and not just t. I guess I could like have a define token concat like t1, t2, and this is just literally t1. How do they do concat? Fuck. I forgot. C concat token. So token paste 2. Yeah, I remember looking into something like this. This is strange. Concat, préfixe, suffixe. Concat, préfixe, suffixe. How to auto-generate unique variable names with the number in them using macro. This is a generic answer, not addressing the narrow specifics of the OP's question, since they are already adequate answers for that. Make unique variable names. Prefix. This. Okay. Okay, why do we need 2 concats though? The problem is that when you have a macro replacement, the preprocessor will only expand the macro recursively if neither the string is eyes. I call it stringify, but okay. String is eyes operator like single, nor the token pasting operator. I called it tokenify in my video. Double #R applied to it. So you have to use some extra layers of indirection. You can use the token pasting operator with a recursively expanded argument. I'm confused. I'm confused. Let's make it simple for now. Let's make it simple for now. I can make it complicated later. It's okay. Don't worry about it. Don't worry about it. So I can just do this everywhere. And so let's also, for now, comment all of those out. And let's just keep the very basics. Okay, and here it returns a dynamic array, this, like so. Yeah, that sounds about right. Except that now I have to to have the implementation here. The implementation here. Isn't there like a slightly cleaner way of doing this? I think it needs to be in a header file, but I think also that there is a better way of doing this. Wait, I need to see generics. Let's see. Generics in C. Oh no, it's medium. What the fuck, float fill? Okay, sure. Yet more stacks. I'm so confused. How is it like a generic? Oh, he just uses like macros instead of okay, sure. Oh no, it does use this. Ah, and you can put a space between them. Okay. Okay, you can put a space between them like so. So that it does it the way I was planning on doing it, kinda. But except his stuff is like you have to declare every single fucking function, which seems insane. I just want one. But yeah, he does what I was planning on doing, basically. Isn't there like a better way? So yeah, from the user side, it says define. Oh yeah, no, so that's the way I want it in the end, I think. Stack tag, tag. I don't know what the fucking tag is, but I think I just want like, it defines an item type, and then it imports a header file, and then the header file takes care of the rest. And like, it's strange because it's a header file that you can actually include more than once. I think that's a good behavior. Yeah, that sounds about right. Then this is maybe the first time in my life where I'm actually going to remove the header guards, you know, like for the stuff to disallow the header to be included multiple times. That feels weird. So we want in the end. And so yeah, we won't need all those weird thing, since the header itself will be kind of the macro. Okay, let's do something like he did. If not the if and def dynamic array type, then we do error dynamic array type not defined, like so, and then and if. Yeah, I know that. Okay. So what I want to do is let's remove all of those. And let's just here define that t is equal to dynamic. Can I do like something like this? Dynamic array type. I mean, I just would like a shorthand. I think it would be handy, but can't I define like just like that? This is equal to this. I wonder if that just would work. Probably. I think it would be okay. And so he does as well at the end undef t and undef dynamic array, which I think is probably good practice. So let's not even wonder about this yet. And let's go back to example. And let's just do define dynamic array type is an int, like so. Yeah. Okay, let's just have a struct for now. Let's just have a struct, and I think as well this C file needs to be fully commented out. Let's see if I can build the thing. Yeah, there is a tests as well. Can I comment out the test as well? So dynamic array type is not defined. I thought it was defined. Here. Dynamic. Oh, fuck me. Then array type. Yes, that. Then array type. Yes. Stray this in program. Oh, so it doesn't want. He doesn't like this. Expected this after top level declarator. Stray this in program. What about? I mean, I don't really understand it, but let's try the token concat thingy. So T1 with T2, and this is like token concat like the recursive one, and then it apparently needs a level of indirection, which don't know why, but Sure. And so I'm guessing I can do token concat, this, and this. Multi-line comment. Where? Oh, yeah. Okay. That seems to have worked. Let's see. Can I do now dynamic dan array of int da like so? Can I just declare that struct? I can. Ooh, that's nice. It's really nice. So yeah, note to self to do understand why this works, because I really don't understand how that works, but okay, now I can concatenate tokens because otherwise it doesn't want to for some reason. And so basically everything that I put in the C file now has to be in this boom, in this header file. So for example this so we need to like define dynamic array. Let's call it dt because I'm gonna use it a lot, which is equal to this. And can I just use dt here, or is it gonna break everything? Like, can I do this? Yeah, okay, still works. So it doesn't consider this one as a token. Okay, so it does like do macro replacement before. Okay, good to know. So can I do then dt? This is dt as well. Xmalloc, who cares? And size of dynamic array, size of dt. And so that's our new. Let's go. Then let's do. I mean, let's try it first. Example. Let's see. Let's just do. So it's an int, and this is. Oh wait, no. Ah fuck! I need to do token concat here as well. Token concat of. I mean, can't I just do t here? I thought I could do that. Huh. Can I do it here then? Okay. Oh yeah, fuck. So it needs to be underscore. And it works. God damn, that's cool. Okay. And yeah, as expected, the implementation side is horrendous, but now that means that, for example, in this, I can include this header multiple times with a float this time, and I can have a float dynamic array, like so. And boom, I have a int and float dynamic array. That's kind of neat. That's kind of neat. And now the question it would be, can we generate like the new generic kind of thing? In the struct, array is still int. Oh yeah, my bad. I guess I can just do t like this. Oh no, it's not DT, it's just T. Unknown type. That doesn't work. But it does work. Okay, my LSP is a bit fucked, but it does seem to work. Dynamic array, H. Unknown type, dynamic array type. Yeah, okay, it's not known yet. But when I compile it with main, it does work. So yeah. Seems to work. Next. Well, let's do the other ones. So I need destroy. And so again, this is token concat of this and underscore t, and this is dt, and I think the three don't change. So here I can delete one, destroy one. Resize will be again token concat, like so, of t, and this is dt, and there is no x realloc. Oops. So let's temporarily use realloc. I'll worry about like errors and stuff like that later. Destroy, resize. I need to implement. Let's implement grow and push. Unfortunately, I don't think I can have like a static const here, because since I'm including the header multiple times, it would declare multiple times the same variable with the same name, which wouldn't work. So I need this to be a macro, which is fine in our case. Grow. Yes, that can be a thing. Or I mean, I could define it as like a static variable, but it would have to be renamed for every single type, every single different types that we have. But I don't want to make it too complicated if possible. So this is dt. And so this is again token concat this t, like so. So this is grow, and now we have push. Token concat of this t. This is dt again. This is t. This needs to be token concat of this t. This stays the same. Unknown name. Ah yes, yeah, same error as last time, but it should compile. If I'm not mistaken, it does. Now we can push. That's good. That is good. And let's yeah, that's it for now. For the print, I don't know. We'll see. So let's go back to the example, and now let's do dynamic array push ints into DA, and we're gonna push like 42 and 43 and 44. Oops, 44, yes. And I think I mistyped this, where this should be with an underscore. So yeah, this works, and now let's do the same for the float one, where this is f. And let's just make those floats. And what I can do is then for size t I, let's I is equal to 0, while I is lower than dA length I plus plus. We do print f of an integer like so, and we do dA array I like so. Then we have the same thing but for floats this time, like so, and put char. Let's just put a new line there and a new line there. Let's see. Does this work? Yes, it does. All right. So that's it. Generics in no, kinda like templating in C, because it's not really, and like yeah, it's not really generics yet. But I don't know. Still kind of cool that it works. I'm already happy. First time I'm doing this, and yeah, implementation side is well, it's hell. With the token concat everywhere. I guess I could make it slightly more readable by defining macros for each of those instead of doing token concat everywhere. Yeah, I could do that. But from, yeah, who cares? But from the user side, it's actually kind of clean. You just say which type you want, include the header, and then repeat. And yeah, then you have functions that are built for you that correspond, a function and a struct that are built for you that correspond to the type you asked. And here in the function use, or in the, for example, this for loop or so, and so on, you don't have to cast it all the time to a fucking void pointer, which is kind of ugly. So yeah, I think it's, from the user side, I think it's at least cleaner than doing it with void pointers. So the user have to define what type they will need before using them. Yes. Yeah, but that, I think even if I like in C, you cannot get really around that. You kind of have to. I mean, it's a small price to pay, you know, like it's like one extra line for like X amount of functions, like this whole code that is automatically generated for you, and like one line from the user side isn't too bad. I mean, it's less user friendly, but I think it's the best that we can do in C at least. Otherwise, you would have to like start hacking into the compiler and see which types the user is using, and then generating the functions only for those types, and so on and so on, which is what C++ compilers are doing. But that seems tricky. So next, I wanted to maybe let's quickly try the generic thingy, but like manually. C11 generic. Yes. What if you want to ship it as a library? Would you pre-generate everything first? No. I would just let the user. I would just have documentation that says that's how it's supposed to be used, and yeah, this is how you can generate it for a specific type. Enjoy. Maybe I could like pre-generate the one for ints and so on, but I don't know. I don't want to add extra bloat to whatever the user is doing. So let's see how this works, because I'm curious. I've never used it before. So the way it would work is we do define dynamic array new, for example, and then we have like t, which is our type. Then we do generic of t. Then we have if it's an int, it would use dynamic array new int, like a comma, then this. And if it's a float, it would use this, but a float. And then we have this and t, like so. Okay, so the generic I guess will expand to the function itself. Okay. I'm slightly confused, but maybe this will work. So can I do but I guess that only works with yeah, that only works if the function takes actually a parameter. Like if I have a function that takes 0 parameter, it cannot really like guess the type of this argument. Yeah, that's too bad. So I guess it would work for like push, but yeah. It wouldn't work for new. It would work for the other methods because they take a dynamic array, I guess. But yeah, I don't know. What about combining generic and void pointers? Would that make sense? I don't know. Why would you want to do that? Is there like a reason? Or I mean, the reason isn't jumping to me right now. Maybe there is. Jumping at me, I should say. What time is it? Oh. Alright, who cares? Yeah, I don't know how void pointers would make sense in this scenario. IG. I don't know what IG means. I mean, someone else said it last time as well. We can use void pointer at the beginning and use generic to guess the type of the parameters. And then, I guess we can use void pointers at the beginning and use generic to guess the type of the parameters, and then we can do the casting internally. Yeah. Yeah, but I don't think the advantage of that. I guess maybe for the implementation side, you would have like, you would split the generic code from the actual implementation, and the actual implementation would be a void pointer. But yeah, I don't know that unless you're like maybe making a extremely complex, even if you're like making an extremely complex dynamic array implementation, where that could be useful for just code that is easier to read. I think if you're making that kind of implementation, you probably care about performance, and doing a bunch of casting all around is bad for performance. So I don't think you would want to do that even in that case. So yeah, not a terrible idea, from the developer perspective, but I know, I think in the case of an educational example, it's overkill, and in the case of a professional example, it's bad for optimization, bad for performance, I think. Or at least I guess, maybe the compiler is smart enough. Okay, so I don't think I can use the new generic thing. I mean, I say this, but I haven't even tried to compile it. Yeah, it does expect an expression. Yep. Generic default. Controlling expression association list. Association list is a comma separated list of association, each of which has the syntax type name expression. Oh, and there is a default expression. Okay. Type name, any complete object type that isn't variably modified. Control expression, sure, expression. I should eat, I think. And I already learned what I had to learn. So, yeah. Compatible notes. And in his example, he does like rename all the thing, right? There is no like things I haven't seen. Stack method push. Like the way he uses it is just to redeclare a bunch of stuff with concatenating. Yep, that's basically what I do. Or implement absolutely everything as macros, but that's... nope. That's not type safe, and also I don't think you could use it in like expressions like this. Okay. I guess the problem with my stuff is I cannot have like a long float or whatever. Because that would create variables that have spaces in them. So that's why he has like a tag for like the structure name and also an item type. But I think a quick workaround for this would just be to do type def long float to my long float, and then do my long float there. No, that doesn't work. Can I do long ints? Yeah, that would work. No, does not. Ah, yes, because generic. But what if I... okay, so I haven't really tested this. Long ints. So yeah, that wouldn't work. But my long ints then does work. All right. So I don't think I need to worry about that. The generic thingy, yeah, I don't know. C11 specification. Is there like other generic tools that generics tools? Type generic expression using the generic keyword. Yeah, alignment, no return, bound checking, quick exit, optional features, criticism. How about C99? Do they have cool things for generic? Type generic math macros in tgmath.h. tgmath. Never use this. First, if any argument for the generic parameters has type long double, the type is determined as a long double. Okay, so they just took all the absolute and so on that are. Oh, they do it. They did it for the complex as well. Okay, I see. Yeah, I guess that makes it a lot easier to work with mathematics. I mean, I don't know about a lot easier, but probably easier. With the declarations, this functions invoked by use of type generic macros are shown in the following table. Okay. Okay. Yeah, that makes sense, I guess. So yeah, they're experimenting with macros through the math part of the standard library. Okay. Hello. How are you? Alright. So no way to do. I don't think there will be any cleaner way to do this. I don't think. We make a game GTR RP person. That's cool. GTR RP person. So yeah, I'm guessing a kind of a GTA clone for something. Alright, I think I will go eat and maybe be back for like a few more hours of streaming. But yeah, I think I have a decently good draft. Now I just need to finish it a bit. Re-add the unit tests for it. Bon appétit. Si. Gracias. Merci. Yeah. A bit sad that there is no like semi-clean way of doing generics in C. But it's better than nothing, I guess. C generics. Yeah, here they talk about void pointers or via args. Yeah, that's the way I could have done it, but casts everywhere when you do that, and also bad runtime worse runtime performance. No, not gigs for gigs. I hate you, gigs for gigs. Nope. Pseudo generics in C. Yeah, that's what I'm doing. That is what I'm doing. The name of type. Actually, I could maybe use this. What am I saying? Wait. So Daymaker new would take a type, but wouldn't actually call it. Wouldn't we be able to do this for like? Ah, yeah, but I have to I have to put the type in it as well. Okay, yeah. It's kind of can I put like a 1 or something? Type. Yeah, okay. Yeah, that doesn't work. That does not work. I could definitely use it for anything else than the new thing, or like the struct name. So I think this is mandatory, like functions that do not have arguments as well will be mandatory, but for maybe the push, yeah, let me quickly test that out. Push, push. Can I use this? Wait, no. It takes something. Ooh. Fuck. Can I then? Can I do this? Definition of DA with different type. Oh, yeah, no, it's just push. Expected type. Expected specifier qualifier list before token. That should work though. So X, Y, then it does a generic on X. Oh fuck, this is nested generic kind of thing. Okay. Okay, this is too complex, too weird. We'll maybe look into that another time. For now, my method is good enough and fun enough, so let's just keep doing that and go eat. You